So yeah, welcome everybody. Like I say, Zoom people, give us a wave. YouTube people, chuck us a hello in chat. Let us know where you're joining us from this evening. We've got quite a varied, coming up fairly internationally this evening by the looks of things. So yeah, welcome to a quick masterclass in Git. But first, just a quick segue on the title there. As I'm sure, no doubt that Dom will reaffirm, this is not in fact the title Dom provided. And if you were to run said command in your terminal, you will have found that it doesn't exist, of course. Now, if you're as unfortunate as myself to have had the auto complete function enabled in Git, you will have found out that you've got now half a second to exit out of running the clean command, a command that I had no idea existed up until about 6 hours ago, if I'm honest. So we'll have a quick look at what git clean does. It removes the untracked files from the working tree. Now, that sounds pretty horrific. I'm sure Dom will let us know exactly what that means later on this evening. But yeah, I ran that in a working Git directory. It was good fun. So we'll move on. There is, however, a one-liner here that I will share to get this git learn command to work. It does come with some caveats that I'll let you check your eyes over there. But I will share that in chat and around if you do wish to have a git learn command. This is the actual title that Dom provided, a nice and semantic title. And as we can see, probably would have resolved in not me cleaning my entire Git directory. But moving quickly on from that segue into the normal proceedings of our events that are coming up. So we've got event-driven development, a quick look at the observer design pattern in Laravel with Joe Dixon from Ubisoft. Ubisend, there we go. I nearly slipped into Ubisoft there accidentally. I'm sure he'll curse me for that. Then we've got a slight TBC. I've just inserted something Vercel, what used to be now. We may have a talk on that first week of August. I have no idea what it is, really. We host the NordevCon website on it, and we're building the Norfolk Developers website on it. So I look forward to finding out what it is the first week of August. Python Lean Coffee, following on from the same format as the Agile React chat, Agile Lean Coffee React. Basically turn up, bring a topic in mind, chat it through. More details on our meetup, of course. Plenty more in the pipeline, and I will move on quickly. Virtual Social Club, join us at the pub. Fridays, 5:30. We go on for quite a while. Bring a funny virtual background. I've forgotten about this actually, but Sean is currently in the lead for a funny outfit. So bonus points if you can take that position from him. We've played Fibbage, Solitaire. This week we're going to try out an app called Ziago. Discord. Join it. There's a QR code on the screen that you're no way you're going to be able to scan in time, but I will drop a link. There's links everywhere. Come chat, come pose your questions, come pose your puzzles, etc. Shout outs. If anybody has a shout out, I will, by all means, this is the time to shout out. Any kudos for success or embracing failure this week, etc. New job in from Dan Smith. A full stack engineer, if I remember rightly, but give us a shout if you're looking for a job. We will find one, I'm sure. But like I say, I'm going to get out of the way, get to the main highlight of the evening, and hand over to Dom. Thanks, Dom.
Hello, the internet. Right, so I need to screen share, which is always fun. I've also got to decide which monitor I'm going to use. Let's go with the big one. Let's just rearrange myself. Dun 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 dun. Let's move you down there, and let's click the screen share button. And I want that one. Can everyone see a digital blasphemy flower?
No.
How about now?
Yes.
Now we can.
Excellent. Right,
Yeah.
we are cooking on gas. As I scroll through the 1,000,001 windows that I have open. Okay, so quite often, this has happened a lot on our Discord as well. People will be saying that they're doing something, and one of the developers, normally me, will pipe up and say, "Oh, you should be using Git for that." Then another developer will pipe up and say, "And you want to be using the command line because that's the best way to learn it." And then we leave it at that, and let the hapless person go on. And it reminds me of that kind of how to draw an owl. Draw two circles, draw the rest of the owl. And we kind of turn around and say, "You must use this thing, it's great," and then provide no further context. So that's what we're going to try and do today, is provide a little bit of context around what this thing is, how to use it, and how to get yourself out of trouble if you've managed to get yourself into trouble, because it's one of those beautiful things that's very easy when it works and a complete nightmare when it does not. It's fairly fluid this afternoon, so if people have got questions, want me to cover things, just shout. Pop your questions on chat and Alex will interrupt me. And we will try and explore all the things that you should see day to day. I should point out that I'm not a Git expert. If you want the absolute masterclass in Git, there's a ACCU video with CB and someone else whose name escapes me, where they go into the absolute technical details of how Git works. I managed to initialize a Git repository and commit things into this Git repository without using Git commands. It's mind-blowing, but we don't need to go to that level. We need to stay at sort of the day-to-day, and we're going to go back in time to start off with, into I think the late 90s. It might be the early 2000s, and something called SCCS, Source Code Control System, which was released in 1972, which, as you can all read, is 48 years ago. So modern software. And if we scroll down, we will see that there are alternatives. And in fact, the alternative I was using was Unix SCCS, which is no longer actively developed, which is a good thing. So this was investment banking, like I say, late 90s, early 2000s. And we had our software in source code control, sort of, insofar as it wasn't something that we controlled. I would write my software, I would send an email saying I want to add these files to SCCS, and the SC admins would add them. But because there was an email involved, you never did it with individual files. What you would do is you write your entire project. And when you were finished, you would go, "Hey, I want to add this to source code control." And it would get added, and then that source code control system was used to deploy the software. So it was actually a very early form of DevOps, but it was kind of a hoop that we had to jump through. It was horrible, and we moved on to another system whose name has just suddenly jumped out of ClearCase. That's the one we used. ClearCase was really good. We used ClearCase, one of the add-ons that made it behave very much like Git. And provided you had the ClearCase licenses, a centralized ClearCase team, 2 people in your team who were full-time ClearCase SCAs, it was a fantastic system. Great if you're in a bank with 140 developers in your particular team, so you could afford to have 2 people. Not great if you're a single developer. So I left the world of banking, and I moved into other worlds where we started using CVS. I don't know if people are familiar with CVS, but CVS was painful. Merges were not something you wanted to do. You would try and avoid merging wherever possible. It was not a fun period of life. And having come from ClearCase, which has its problems but actually worked, it was a dark period. Then came Subversion, and the story is that when they wrote Subversion, if they got to any complicated questions about how should we do something, they took their cues from CVS. So there were still some issues. Merging wasn't great, but it was better than CVS. And then came along Git. And the story there is that when they came to the complex questions about what should they do, the question was, what would Subversion do? And they did the opposite. And Git actually made merging things much, much easier, and merge conflicts much, much easier. So it allowed for improved branching. which is the main reason why I started getting into it and started using it. There's a whole bunch of other stuff that it does better. And it has taken over the world of source code control. I mean, there are other systems. There's Mercurial, which some people still use. And there are other proprietary systems. So Git is by no means ubiquitous, but it has become very, very common. But there are some caveats. It's very user-friendly. It's just very picky about its friends. There's also a lot of confusion about what actually Git is. So I have here a Bitbucket tab, although other vendors exist. There's GitLab, there's GitHub. So when people are talking about Git, they quite often start talking about GitHub, GitLab, Bitbucket, and there's this confusion about I use these things. These are built on top of Git. These are not Git. Git lives in the command line, and I have here the command line. There are UIs that you can use that can make your life easier. I tend to like working in the command line for most things. We'll see where that doesn't hold true in a bit. And what we're going to do is we're going to actually go create a new repository. That's a Bitbucket and Davis. And then we're going to call it something. Let's call it dir nordev. Dom's first rule of typing, the ability to type is inversely proportional to the number of people watching. You'll notice a lot of mistakes. Right, so we need to initialize Git. Actually, let's take a step back because I'm aware that there are some Windows viewers. If you're using Linux, it's probably already installed. If it's not, apt-get git or sudo apt-get git. If that doesn't work, sudo yum git. Otherwise, just look up what documentation for your whatever package manager. If you're on a Mac, it should be installed. If it's not, brew install git. If you haven't got Homebrew, go search for Homebrew. If you're on Windows, there's a bunch of different ways you can get it. I believe Sigwin comes with it. There's also gitbash, which provides you a bash implementation with Git in the horrible command console window that has existed since Windows 3.1.1 and still has awfulness from there. Apologies. Everything that happens with the text is the same. Your windowing and your copying and your pasting and your life will be different. Get a better operating system. Anyway, Git is installed. We need to initialize our Git repository. Now this is complex, so we'll go over it carefully. Git because it's the Git command. Init because we want to initialize a repository, and we're done. That's all we need to do. Now, what's happened under the covers is that we have a new directory, .git, and inside is stuff, most of which we could ignore. In fact, I would recommend that you don't fiddle with anything in here apart from this thing, config, which you might need to play around with, might not. It's up to you. Okay, so what can we do with our Git repository? Well, we can put files into it. Most repositories have a README, so let's shove in a README.md. There we go. Right. Let me just do something. Bash RC. That's better. So my bash RC has some extra funkiness in it that highlights the command prompt, but also tells me what branch I'm on with Git. We will ignore the whole, whether we should be calling it master or main. By default, Git uses master. It's quite easy to change it. Anyway, so we are in our master branch. We've initialized our repository. We have a README directory in there, but it's not in Git. It's not tracked. We need to tell Git that we care about this file. Git add. Now we can be lazy and we can say git add dot, or we can be specific and say git add readme.md. Now git add dot will just add everything in the current working directory. If you've piled a whole load of stuff in there, that's what will happen. So you'll see now that we have no commits yet, but we have changes to be committed. we have a readme.md. The previous one, we had untracked files. In fact, let's do this. Let's touch untracked, do git status. Now we have a file to be committed and an untracked file. Git clean. Ooh. Refusing to clean.
Turns out it needs a -f.
Oh, okay.
My
Git's obviously set up in a much more sensible way than I haven't used git clean before. Where's my untracked file? Well, git clean will remove any files that are not tracked. Now, this is great if your build system spits build artifacts everywhere that you don't care about. This is not great if you have a whole lot of local files that you rely on that suddenly get deleted after what the default timeout is because you're trying to prove a point about a command that's inaccurate. So what have we learned from this, Alex? So that's the fun that Alex just went through when he had his git clean try to run, was all those untracked files were going. But we've got a staged file. This means that a change is ready to be put in the system, but it's not actually been actively tracked by Git yet. For that, we need to commit. Git commit and then dot. So we're just going to commit everything. And what has happened is, let's up here. This has happened. It's fired up Sublime and wants me to put in a commit message. Now, I know what you're thinking. What is this? How do you commit out of it? I mean, don't worry. I've used Sublime before. I know how it works. If you want to use Vim, Emacs, anything like that, there is a variable you can change, and you can use whatever editor you want. But here we're going to put in the commit comment that everybody uses when they first put something into Git, initial commit. Close that window. And we've inserted a file. Nothing to commit, working tree is clean. So everything is now in Git. And when I say everything, I mean a blank README file. Whoa. So maybe we want to make some changes to our README file. Read this. Oops. Git status. Our file's been modified. So we can commit those modifications, commit those changes, put it into Git so that we've now got a record of the changes that are made, or we can turn around and go, actually, those changes were ridiculous. Let's revert them. But we're going to commit them because reverting back to an empty file is not necessarily a good idea. So let's git commit -a. So the -a is all. My editor fires up again. It's fired up on a different monitor. So what we'll do is we'll put in a git commit message, add some text. Save that, write that. And I will go and change the editor. So Git uses, I don't know where this lives in Windows, but in, oops. In my setup, it's .git config in my home directory, same for Linux users. So there's a bunch of different things that you can set globally for Git in this particular file. And one of them is the editor. I don't know if you can comment this file or not, so I'm just going to make a copy of that, and let's change that to that. So if I now go back to my previous dev, because I'm clever like that. Right, add some text. We've got modifications, so we can git commit. I'm going to use a different way to commit it this time. I'm going to git commit with the file name. So now it's fired up Vi to put in my commit message. So you can actually see that coming up. You can use whatever you want to write your commit messages. As long as your editor can be launched from the command line, it's absolutely fine. Oops. Body text. Okay, so what does all this mean? Let's type in git status, we're all fine. Git log. I'm going to put in a switch git log -1 line because we want to just see a few things. So we've got a history of what's happened. We've got this funny number here, and we've got our commit messages. And what this is a history of what has happened to my file. So if we cat readme.md, it's that. If I was to check out this revision, it's gone back to what it was before. Now you'll notice we've had a bunch of warnings and a bunch of weird stuff happened here. So first of all, it says I'm in a detached head state, which sounds a bit weird. But what it's saying is I am looking at something that is not at the top of the working branch. I'm not at the very tip of where development's happening. I've gone back in time. So the changes that I make here are not going to be saved. It won't let me save them. And then this weird thing here just tells me that I'm on commit rather than at the tip of where you would normally be working, so the edge as you build out. So we can go back to head. No. Let's go back to that one. No. And this is where I get what have I done wrong? This is where it gets absolutely fun, because once you go off the beaten track, it starts hitting you with good fun. Let's revert to that. There we are.
You need git checkout master.
Checkout master. I was doing head. Thank you very much, Alex. Once you get yourself in a tiz with Git, you're in trouble. So there's some other things we're going to look at later, where we start looking at conflicts and how you resolve conflicts and how you resolve changes from different sources. That again, you can get yourself into a real tiz. Now these funny numbers are your your commit hashes. They're a unique hash of what your commit is, and allowing you to just navigate between the different commits. And they should remain static. So if I was to push this repository up to Bitbucket, which we'll do in a bit, I should see these identical hashes. It is possible to change them, and there lies a whole load of problems, which is why people sometimes get a little bit sort of like, what's going on with Git? Anyway, we've made a bunch of changes. We want to share these with the world. So we're going to create a new Bitbucket repository, and we're going to call it moredev. Oops, so project. Let's put it under fun. Make it public because people might want to look at this. Create the repository. I haven't included a Readme because I want this to be created empty. We've done this. We've gone to our repo. We're going to cut and paste this command. Git remote add origin. Blah. So what that's saying is Git, please add this address as a remote repository. So somewhere else that this repository lives. And then we're going to say, push everything from my machine to that remote repository. And if I reload here, there's my README. And if I look here, here's my set of commits with the same commit hashes, excuse me, that we had before, which is Fun. So like I say, all this stuff is just built on top of Git. Now, why is this useful? This is useful because we can actually start tracking what it is that we've done to a particular system, to a particular file, as we're making changes to it. And if you get into a habit of actually doing commits regularly, you can start seeing the thought process that's gone on as you're editing that particular file. One of my massive bugbears is where we've got, let's pretend this is code. I'm going to do something to prove a point, and then people commit that. And you've got commented out code, and you say, why have you commented out the code and committed it into the system? And it's because we might forget that code's there. We might need to reinstate it. And it's like, well, you don't need to store the commented out version. You can just go back in time with your Git versions, have a look at what that file looked like in a previous iteration, and pull the code out should you need it. There's no need to leave chunks of commented out code in your file. And we can demonstrate this by let's take the comment out for now. Let's and we're going to use a different version of git commit, add some text. So the -m flag says I want a message, and I want this as my message. So rather than launching up an editor, it's going to just take that as my commit message. Going to push this up to my origin. So git push this up to a different system. Origin is just the name of the Bitbucket remote that we've got. Master is the branch I want to push up. Boom, 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 boom. And oh, I've got this. Add some text. Fantastic. But let's pretend I've got a build system on here, and I've just broken the build. And it's this line that's broken.
Dom, could you show
Yes.
us a bit?
I will do in a bit.
Yeah, cool.
So let's just pretend I've broken the build. Oops. Git commit dot -m. Oops. By the way, these are not good commit messages. Do not. Master, dun, 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 and now we've got committed out code. Oh, someone do that. There's no need to comment that code out. You could delete it and go have a look at what you had before. And how do we do that? Now, I'm looking at this and I'm going, right, well, I added some text, and I added some body text, and then I added some text, and then oops. What did I do in each of those steps? And this is where your git commit messages start becoming really important, because the amount of times I've seen fixed typo, I've done that a lot, fixed bug, I've done that a lot as well. And then you come back to sort of go, where was the thing that I made the change that I want to find? I don't know. It was when I added some text, but all of them are adding text. This is not useful. So perhaps we want to start being a little bit more descriptive with our commit messages. As it is, there's only 4 commits. I did it 2 minutes ago, and I can kind of remember what I did then. So I can go back this way. I can go back and find out what it was that I had in there. Okay, so it's a way of keeping a history of what I've done. Great, seems like a lot of overhead. Why bother? It is very useful, but one of the things that Git allows you to do is to go off and make your own branch and do your own things without breaking things for everyone else. So if I check out -b, so -b says I want to create a new branch. I'll set this up. Let's just call this branch A. Normally, I would tie in my issue tracking system with actually, let's set it up. Let's show this working. Repository settings. Let's give myself a an issue tracker. Let's make it private so I don't get spammed. that going? Yep. Issues. I have issues. Let's create an issue. Let's pretend we broke it. You broke it. Assigned me. So I've got issue 1. So I can issue 1. There we go. The thing here has changed. I am no longer on master. Any changes I make to my code will not affect master. I can do whatever I want here and not have to worry about affecting anyone else. Let's see what we did. Our build system doesn't like, oops, our build system doesn't like apostrophes for whatever reason. Making this up as we go along. So it actually turns out that my fix is this after many hours of checking. So we're going to git commit readme. Oops, fix. That's an interesting thing. This is not a feature of Git per se. This is a feature of a lot of systems like Bitbucket and GitHub. You can reference issues in your git commit message, and magic things will happen when these go up. Remove. So, yeah, that one. C. Is that spelled correctly? Build. System does not like them. Right. There are rules, guidelines, I don't know what you want to call it, about writing git commit messages. And the idea is to treat it a bit like an email. So your headline, your first line, is always a short, advisably 50 characters or less statement. No full stop on the end, and it wants to be written as an action. So we'll notice this when we start looking at rebases and the way that the Git does stuff. You want to do it as if what happens when this is applied, when this particular change is applied to my code. So we don't do removed, and the past tense, we do remove. So when you apply this, it will remove the superfluous apostrophe. We can then use the body underneath, new line, then do the body, which is generally trying to limit to 72 characters, but you can go up to 80 if you want to, where we start putting in a more complex message about what it is we did, what the thinking behind it was. And what you'll find is if you do your commits often enough, you often don't need to put in a body. Your headline messages are enough. If you're doing larger commits, then maybe you do want a bit more explanation about what's going on. So we can write that in. We can git push origin, and we're not pushing master anymore. We're now pushing this branch issue 1. When the whole thing wakes up. Okay, so this popped out. This is a feature of Bitbucket. It's a commit hook. When you push in, Git Bitbucket will spit out a URL for you to create a pull request. I don't think GitHub does this. At least it did last time I used it. But you can go off and do the same thing in GitHub. But if we take this magic URL, shove it in here. I'm using my private browsing mode. And of course, it's not remembering who I am. Okay, so this is going to create a pull request. Now, this is all part of Bitbucket, not part of Git. But Bitbucket, GitLab, GitHub all do the same thing. And you can do a similar thing within Git itself. What we're doing here is we're saying, I want to make a change. I want to put that change on our main branch, but I want people to have a look at it first. And this is showing what Alex was saying before, a diff of what's changed. So it's showing you, here is the change going in. This line has changed, and we have removed a comment and altered this word. And we should be able to, some people find it easier to view it like this, side by side. So that's what it was, that's what it is now. I tend to have the unified, so that's what it was, that's what it is now. The minus is we're removing this line, we're adding this line. So I can then turn around and go, ooh, I'm happy with this. This is a good change. Approving it again is a Bitbucket feature, not a Git feature. And then merge. Now this is a Git feature. What this is going to do is it's going to take the changes that I made in my branch and apply them to the main branch. And it's actually closed this branch off. So if I go back to the source view, we've got this change that I put in. Now, if I check out my master, the change isn't here. And the reason being is a Git repository is, or Git itself is a distributed repository system, so it can exist in lots of different places. And what you do is you need to sync up the repositories, and that's what you're doing when you're pushing and pulling, is you are syncing up the different copies of the repositories, and the copies are complete. With things like Subversion, you would have a central server that held the repository, and you would make a copy of that, make changes, and then upload those changes. But the central server was always the source of truth. With Git, it doesn't matter. You have n Git repositories, even if it's just on your machine and just one repository, and you get to decide what the source of truth is. Normally, you will say the source of truth is your GitHub or your Bitbucket or GitLab repository, but it's entirely up to you. So I have made my changes locally in a branch. I have pushed those up to Bitbucket, and it arrived in the branch there. I have then merged those changes from that branch into the main branch on Bitbucket, but I have not made that change locally. Now, the way we do that, we don't want to merge things locally as well, because that'll just confuse things. What we want to do is pull the latest version from Bitbucket to where I am. So this has pulled all the changes that have been made, and this might not necessarily be just my changes. This could actually be other people's changes. And now we can get the Readme, and we are now up to date. So it's something you want to get into the habit of if you're using Git, is to actually pull down the latest changes of things so that you are up to date before you start doing work, because otherwise you can get out of sync and end up with differences and conflicts. So that's a very basic overview of branching and merging back in. And one of the things you'll notice with that magic commit, my issue is no longer open. It automatically closed it because I said it fixed it. There we go. Now, I tend to work with a very specific workflow, which sorts 95% of everything I'm doing. Before I start work, I want to pull the latest version from master. So I want to do a git pull origin master. And then I want to create my branch, which will have a very fixed name. Normally, we use Jira quite a lot, so we'll normally have the Jira issue number as the branch name. I then make all my changes. I then want to push that branch up to the centralized, or the blessed repository, whatever you want to call it. The thing that we've decided is the important repository, in our case Bitbucket, so that people can look at those changes. They get merged across, and then I want to pull those changes down, and I want to get rid of the branch locally because I don't need it anymore. If I do git branch, I've got these two branches. I've got master, I've got issue one. I'm going to delete issue one. Don't need it anymore. Clean things up. So that's the workflow that I use, and I've scripted this. Git has this interesting feature, Alex alluded to it earlier, where you can create your own Git commands. And I have, let's fire up a new tab for this. Loads of stuff running. Yes. So I have symlinked the Git bin directory to .bin, so I can keep all of these in Git. And basically, if you create a script or an executable file, it could be a binary, and prefix it with gitdash, that becomes a Git command. So git done, git new, git review, and git update are all commands on my machine because I've put these in here. And if we have a look at there's some formatting that goes on with the issue number, and it just checks it's correct. But what we're essentially doing is just doing a git checkout -b issue. And oops, can't get yeah. This works out what branch we're on, pushes that to the origin, and then, if you remember that URL came out, it grabs that and opens it up in Safari for me, so I can go have a look at my pull request. And then the last one we'll look at is my git done, which goes off, checks out master, pulls master, and tries to delete my branch. Lowercase d will only delete a branch if the changes have been merged into your main branch. So it's a save command to run. It's not going to delete anything that's not saved. Uppercase D will delete a branch regardless of whether it's been merged in or not. Sometimes you'll want to discard the contents of a branch and you'll want to use uppercase D, but I would use lowercase d to start off with. If anything, it's just a hint that maybe you haven't merged stuff in. So with those, I can now oh, I did that in the wrong window. Oh well. It's fantastic. I can do that. That's my script running. New is not a git command. That's my command that I've written. And it's literally just syntactic sugar. I could have done git checkout -b issue 2. On this window here, I don't spell my own name correctly, not have. And no, actually, what we're going to do here. We're going to go to the root on this, and we're going to clone this directory. Bitbucket gives you the full clone command. GitHub gives you the address to clone. Just something to remember if you're bouncing between the two, because it can sometimes be a pain when you've typed in git clone and you get it already. So I'm going to clone this repository a second time on my local machine, but I'm going to call it nordev2. And there's a reason for this. I've done that in the wrong directory. Actually, no, I haven't. I'm fine. So this is taking a copy of the Bitbucket repository, pulling it down to my local machine. If you were to join my development team and needed to work on the code, this is what you would probably run in order to create the repository rather than initializing it from scratch. So if I go into nordev2, here we are. I'm on my master branch, my main branch. So in this directory, issue 2, in this directory, it's a bit bigger, oops, in my nordev branch. We have multiple issues because it's software and these things happen. For issue 2, we're going to make this change. It's a title. This needs to be a capital T. Fantastic. Git commit -m. Oops, no. Title case. Dun, dun, dun. For this issue, what are we going to do in this one? Oh, we've got too many new lines, so we're going to delete that. Let's get the spacing correct. Git commit. Spacing. Great. So, 2 developers, 2 changes. Git done, my command, that's going to do the, no, not git done, git review. My command, that's going to go off, push it up to origin, note the URL that comes up, and open in the wrong window, ignore all the tabs, my pull request. Same with this one, pushing up our change. And it's going to open up for the pull request. Now it's a race. The race is now on. Who is going to get their issue reviewed and sorted the fastest? I live in Chroma, which is in the middle of nowhere. My internet is slow, and I've got a video conference going on, so apologies for all the spinnies. So my change here, that looks good. My change here, that also looks good. And while I'm here, I'm just going to merge this in. Fantastic. So that's going in. That change is now being applied to our main branch. I now need to apply this change, merge that in. This has been applied to my main branch. Now all of that worked. That's fantastic. If we were using CVS or Subversion, the universe would have imploded at this point. We've made changes to the same file and it just never ever went well. All of this worked. So if let's actually just do my git done command. So that's going to switch to master, pull the changes, pull it out. Both changes are there. Now, the reason I was able to do that is because the diffs were in different places. Let's not pull the changes from master. Master is now ahead with some commits, but I'm going to continue messing around on this branch. I shouldn't do. This branch is now dead, but I'm going to do another change. Maybe I've forgotten something. Maybe I think, oh, actually, yes, this needs to, let's just tidy up something while we're here. Tidy up the line spacing, get rid of that. Wait for that to do its thing. Let's get those. And create my pull request. I've got problems. I am 3 commits behind master. Now, Bitbucket is quite nice. It'll allow me to sync things, and we'll do a merge, and this is all nice and fast 40. And it's actually realized, although the line changes are identical, it can work out that actually the things we're ending up with is fine. But I've now actually got an extra commit in there that I didn't need because I was out of sync with master, and I'm going to mess things up a little bit if I merge that. I'm actually going to end up with more commits than I want. What I can do, let's close that. Let's check out master. Let's pull my changes from master. Let's check out issue 2 again. And there are quicker ways of doing these commands. I'm not going to go through them because it's actually easier to just be on the branch you want to be messing around with. Get into the habit of doing that. You won't get yourself into trouble. I've been using Git for a long time, and you saw me earlier on get myself into trouble messing around. So I tend to take the simplest route, even if it's slightly more typing. So I can do this magical command, git rebase. What this says is take my issue back to where I took it from master, then replay all the changes that have happened to master, then replay all my changes on top of this. So this has actually pulled in things from issue 3 that we pushed up. Now, remember what I said about all of these hashes need to be the same. If I try and push this up, it fails because I have a different history here compared to what I have in Bitbucket. This is one of the problems of Rebase. Rebase rewrites the history, and if you're sharing that history, it causes problems. So it won't let you. However, because we're working in branches, and because the branch is my branch, and no one else should be working on it really, I can get medieval. I don't care about the changes that have been happened to the history. Make my history the real history. This should now have, it's over here now, updated my pull request because I've made changes. And actually nothing has changed because the changes I've made had already been made. So what happens, let's just get those. Issue 4 and 5. What happens if we go fiddling with the same thing? Put a full stop on the end there. And
Dom, you did get issue 5, you didn't do get your command thing.
So I did. Yes, get new issue 5. Now, one of the things to note is that Git will actually carry our changes over. If I git status, there we are, we've got modified. If I do git new, which is just doing a git checkout -b, issue 5, it will copy across that change. The little m there means modified. So I'm still in the same state. It's not a problem. And even if I'd actually committed into master, we could have done some funky stuff to sort that out. That's part of the reason why I have this set up. So you can see that we're in master. Doesn't always work. So where were we? We were git commit dot -m and full stop. I'm lazy. Dun, 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 dun. That's going to load that up. We'll go off over here. And did I do the same thing in this window? No, I didn't. Now on this one, I'm not sure if you're aware, but you really should have a blank new line at the end of files because it causes tools to have problems otherwise. -m and blank new line. Now that doesn't look like it's edited the same file, the same line as the other one. It'd be interesting to see whether it will allow me to do this. So again, 2 pull requests open. Let's create this pull request and let's shove this one in through first. Approve that, merge that. Yay. Create the pull request. Oh, there's been a branch change. Let's view the change. The reason why it's not showing me any changes is because it's master that's changed. And I'm hoping, yes, we have a conflict. And that's horrible. There's chevrons all over the place. There's equal signs all over the place. There's some nasty hashes there. What's going on? That does not look nice. Now I need to fix that conflict. It should tell me how to here. No, it's going to want me to sync. Right, so what I need to do, because I've done this before, it's issue 4 causing the issues. Let's check out master. Origin. Okay. Issue 4. Master. We've got our issues again. This looks slightly nicer. It's used the fact that this is our head commit, and this is the commit message we used. So it's not using the git hashes. Slightly easier to read. And what this is saying is one file has this line, and the other file has these two lines. How do I fix this? And what you need to do is to get the file into a situation where it looks how you want it to look. And this is where I leave the command line and I go off to an IDE. So we're very quickly going to add, oops, this project, import into my IDE. And we don't have to do this in my IDE, it's just why make life difficult for myself. And you can do this in whatever IDE you like. Where am I? Nor dev 2. Nor dev. Don't open that. Okay. And we should magically appear. It didn't feel like it worked. That didn't work. Let's try that again. This one, nor dev, open. Module from existing source. That's better. And that should now magically appear. There it is. Okay. Now that knows there's part of Git. This is what I've got coloring set up. And again, we've just got this horrible. But I can right click and I can go to Git and I can say resolve conflicts. And I can get this lovely view, which has taken out all the rubbish and allows me to see that this is from issue 4, where I was. This is from master. And I can turn around and say, well, actually, I want that. Let's take that change. And also I want that because that's my change. So let's take that change as well. All changes with this. Let's save the changes. There we go. Now, I'm just going to delete that new line. My IDE shoved in a new line because it's set to do that. Now we've finished with our changes. Our rebase is finished. We're all good to go. We're going to have to force this because we've done a rebase. No. Actually finished. Oh, I need to finish my rebase mark. Let's continue. So when you're rebasing, because it's replaying work, it's gone back and it does commit at a time. When you have problems like that, you need to. I'm just going to copy that. God, can't talk and type at the same time. It came to a problem, so it said you need to fix this problem. Now I need to continue. I need to mark them as resolved, so I need to git add that to say I've fixed it. No. Ah, interesting. Let's put that new line back in. Let's have it how it was. There we go. Cannot type to save my life. There we go. There we go. So we're now sorted. Probably won't be able to do that because I've made changes, but it's fine. It's my branch. I don't care. Let's just force this up. Let's appear up here. This has changed. The page. Great. So we can merge that in. And this is where everyone says, oh, you must use the command line. This is true, and I do use the command line for a lot of things. Oops. I use the command line down here for a lot of my checking out, checking in, pushing, pulling. But actually, I tend to use my IDE for conflict resolution because it's a lot easier, and also for diffs. And there's a reason why. Let's add some changes here. Those changes could have been quite complex. I might not remember what it is that I've changed. I mean, my IDE is nicely trying to tell me what I've changed, but I can go and say, I would like to see what that change was. I get this lovely diff view. And when you've got some quite complex changes going on a piece of code, it can be quite nice to see what's changed where, even before you've actually committed that in. Now, it is possible to do that on the command line, but that's not particularly readable, and I can never remember the syntax because I never diff on the command line anymore. Much, much easier with that lovely side-by-side view. So yes, and also I tend to just commit files. There is a shortcut, but if I commit files, this allows me to actually pick which files are going in, so I can make sure that I'm committing the stuff I expect to be committing. If you're committing often, you shouldn't be having huge walls of things there. And then I can put in my commit message. And if it's long, then this happens. It's set up with the guidelines to say, keep it nice and short. And there's also a line here to keep my commit message nice and short and sweet. So it's a kind of a hybrid approach, and you'll actually find that either your IDE will have the tools that you want to use, or there's a UI that you find is quite useful for you to use, and a combination of that and the command line is normally the way forward. Start with the command line just to get a feel for it, because pushing and pulling and what have you can be quite fun in UIs. But where things are just annoying, like fixing conflicts in an editor that doesn't do side-by-side views, is just an absolute nightmare. Now, one of the things that is nice about all of this is we've now got a history of all the changes that have gone in, all the commits that have happened, when they've happened. So if we go have a look at something slightly more meaty, actually that's probably a bad one. Let's find other games.
It's a meaty project with a README file there.
Yeah, well, yeah. I haven't actually committed that one in. Oh, this one's great. It's an open source project I work on. So lots and lots and lots of commits. This thing down here is actually showing what's going on. My changes tend to be small, so make a branch, fix the thing, check it back in, because I'm only doing small changes. This was a little bit more chunky because I was doing a slightly bigger change. But I can pick any one of these commits and actually find out what it was that I did in this change. And I can do this from the command line as well. I can sit there and I can say, right, these are the changes that happened out of all the code, and the code base may be quite large. These are the changes that happened. And if you're keeping your commit small, you can see the differences within each one. You can see the code evolve. If you're keeping your changes, your overall changes small, you can actually see what's happened in that particular change, and it becomes easier to grok. So if someone's doing a code review on this and having a look at it and going, what's happened in this particular change, what I'm doing is I'm defaulting a status code. If I have no status code set, I'm setting it to HTTP OK, and then I've written a test. A code of 0 will be treated as 200, and I've written a test for that particular change, which I'm glad I've done, because it's something I preach and don't always do. So your IDEs, your UIs, your online tools such as GitHub and GitLab and Bitbucket allow you to view these diffs in a very nice fashion and see what's gone on with particular changes. And it can be quite useful to find out what's caused an issue, for example. Code used to work, code no longer works. What is the difference between these 2 points in time? And it doesn't necessarily have to be a change of a single issue. You can turn around and say, right, give me the difference between this commit where I know it worked and this commit sometime later where some developers may have trodden all over the code, and just get what's changed in the system. What else do we want to look at? Oh, merging. So we've looked at rebase. We've said that rebase isn't always the best thing to do because it rewrites the history. So when we put things back into our main branch, so we don't break things for everyone, we actually merge it in. Now, merge is different to rebase. Rebase goes back to where you branched and then plays all the work on that branch on your copy, and then plays all your work on top of it. Merge just says, take this change and apply it to the branch as a new change. So if I'll do my merge locally. Do I have any changes here? Let's do it in ID, it's just quicker. Add some changes here. And then we can git file. One of the other things with the ID commit is I can actually see the diffs that have gone in. I can see what's changed. So I can just quickly go through and do my own little internal code review. Right, let's demo merge. Cool, git checkout master. Now, if I try doing this, git branch -d issue 4, it won't let me delete it. It's not fully merged, which is a good thing. So I can git merge issue 4. I hope this state's correct. It's been a while since I've done that. Yes. So that has taken that issue and just merged it in the master. So it's not rewritten any of the history. I can now actually I might not be able to push it up. Maybe yes. I've made changes on Bitbucket that I didn't pull locally. That's fine. Let's just take that. There's an interesting one where Vi has now opened up in a tiny window. Have I got myself in a tiswas? No. So what's happened there is I have taken all the changes from master and it's replayed them on my local branch and then applied my change on top of that. Now, because the history has not changed relative to where I'm pushing, I didn't have to force. It's only when the history gets changed. This is one of the things that confuses people when it's like when to rebase, when to merge. Rebase really should only happen if you control the final branch or if you're trying to catch up on your main branch. I would suggest keeping your main branch up to date, but if you've got your own branch, don't try pushing rebases around as a kind of update. Just force them out and make sure no one else is using them, or merge your changes in and push that particular change up. You can mix, which way around does this go? You can mix merges and rebases, but you can't mix rebases and merges. If you're rebasing your changes, if you're merging into your branch and then rebasing that into master, you're going to end up in a world of pain. If you're merging into master but rebasing your local branches, that's fine. Just treat your local branches, this is my thing, I can do what I want with it. And I would keep your local branches short-lived, a day, 2 days. Otherwise you're doing too much and it's not agile. So one of the other things that we can do is we can actually share this Git repository with other places. We all know that Bitbucket goes down, GitHub goes down, GitLab goes down. So we can, in fact, be resilient to that. I'm just going to use this one. GitHub. Please still be logged in. So I can create a new repository. And I can call this, I think I already have a dev on here, but let's just go. Make this one private. Not initializing it because I want to put my code in there. Again, commands. Now I've already got an origin, but the name origin is actually arbitrary. It's it's convention. So what I can do here is I can actually call this, I'm going to call it GitHub. So I've now got a remote called GitHub, and I can git push -u. -u just says push everything, including tags and everything like that. GitHub master. Up that goes, and my repository. It's now on GitHub. Now, we tend to have other things also tied into our SaaS platforms. So you've probably got pipelines and various other things, but if you're using Git correctly, just because your origin has disappeared for whatever reason, it should not stop you from working. And you can host your repositories anywhere, including local. So you could have an AWS instance with this set up. You can have a machine in the office that is just a little blessed server that you can push to. You can even have your pipeline say, well, I'm going to take this code and actually shove it onto GitHub and GitLab, just so we've got a copy of the code somewhere else. And you can push everything, all of your branches, all of your changes, and just keep them in sync. Git is distributed. There is no need for there to be a single central point of failure. More of a problem with your pipelines and everything, but that's a different talk. Now, one of the things that Alex said he did not understand was tags, and I'm just looking at the tag thing here. I'm going to do this in Bitbucket because I'm more used to tagging in Bitbucket. So we've seen branches. You make a branch. A branch is basically a copy of your code. You make changes to your code, and then you can sync that back up with the main, with master. And you have these points in time, which are tagged with this commit hash. But you can also turn around and say that, actually, I want to give this a more formal tag name. So I'm just doing this through the UI because I tend to kick off builds with tags. So I do it from here. It's easier, but you can also just type in git tag. Let's try it from the command line. Let's see if I can remember the syntax. I think it is just git tag. Nope. Not going to give me any help. Tag 1. That's my memory served me well. Yes. There we go. A tag is, think of it as an immutable branch almost. I can check out a tag. Can't make any changes to it, but I can check out that tag, and I can actually have more than one tag in there if I want to. So I can. Yes. So again, detached head because I can't really make any edits here or anything, but I can check out my tag. I don't have to remember this nasty hash for a particular version. I can just say, right, I want to go and have a look at this version. And this becomes useful for when you're promoting things between various environments, when you're turning around and saying that this is a completed iteration, or you want to mark it in some way. I will also use tags if I am about to massively refactor something. and I know that there are going to be multiple commits over multiple weeks, and it might go horribly wrong, and I might want to go back to the initial state where it wasn't broken. So I might go git tag worked here, so I can just commit back to that. So you can within, and I'm sure you can do this on GitHub as well, you can just create your tags here. No space. And you put the description in there. So there's nothing fancy about them. They are literally just here is a point in time. And then when we have a look at our commit view, you'll see that there are some tags here. And if I, that's going to pull the tags. Let's just see if we can pull the tags as well. Nice and fast. Yeah. Now, does it show this on this one? Yes. So you'll notice here, this is my head, it's my master branch, but I've also got this tag and this tag. The reason why I'm typing in -1 line with my git log is because if I don't, I get a load of extra stuff that I don't care about. And it becomes much easier to read if it's all one line after the other. If I've got more detail that I need to see, then I might do the full one, but I tend to just use -1 line. So it's nice and compact. And you'll note we've built up quite a history of stuff already, just with this sort of messing around. And we can, what's the format for gitdash? I'm doing my ID. Git compare with. I can turn around and actually compare with any particular version of that file and see the changes that have happened. And I can also do that at any level. So at this level, it's just saying I've changed one particular file, and I can go in and have a look at what's changed in that particular file between those points in time. So that is a basic crash course in the workflow that you would need with Git. Some places have more complex workflows where you will have a main branch and a development branch and a release branch. There's this thing called Git flow, which I looked at and I tried to use because it was flavor of the month some years ago, and I could never get it to work the way I wanted it to work. I have always had a main branch. Your changes go off, your branches go off the main branch. This is, I'm fixing an issue, I'm introducing a new feature. And when I'm done, I'm going to put it back into the main branch. And then when I'm happy, I am going to tag the main branch, and that is the release that goes out. And that gets rid of the need for a production branch and a development branch. Now, you've got to keep too many moving parts in sync. I know there are some places that will cherry pick. Oh, that's something I haven't shown actually. There are some places that will cherry pick various changes. Let's quickly show cherry pick. Can we do this with a single file? Yes, we can. Let's go back to here. So I am going to branch. No, git checkout.
I'd love to know a good reason to use cherry pick before you proceed.
Oh, very, very simple. It allows you to take a tiny portion of a change, a very tiny portion of a branch. Now, the reason why I would use it is because I have disappeared up my own backside somewhere trying to fix something, and then I realized that, oh, hang on a minute, it's just this one change I made in this one file, and I could ignore every other change. And rather than sort of, oh, how do I unwind this? We can make some changes. So we're going to check out. I'm going to just call it Cherry, and we're going to very quickly make a bunch of changes to our to our file. So one. Let's just do this nice and quickly. Two. And 3. Good, solid changes there. All on my branch. And then I was like, oh no, I'm an idiot. I don't need 1 and 2. So I can get reset. Actually, let's get log. One line. So this is where I came from. That's the origin of my branch. Git reset that. Now my reset has taken me back to there. I don't have those other commits, but I've still got the changes in my file. Perhaps I didn't want that. Let's do a hard reset. I no longer have the changes in my file. But I actually wanted this change. This is the one change I wanted. Got some conflicts. Actually, let's do this. Let's do this. Let's do this hardcore. Now that's interesting. Do the end of lines. Lots of actually read. I mean, it's told me there in lovely yellow text what I should do, and kept my commit message. There we go. So that cherry picking, if there hadn't been a conflict, would have allowed me to seamlessly actually take those changes and just the changes I want. Now, some people use cherry picking to turn around and go, right, I want this commit that represents this issue. So you've done your pull requests into your development branch, and you have commits that represent a merge of a change. So 2 developers have done changes, and you can say, I only want one of those changes. So I will cherry pick from my development branch into my master branch and just take that one change. That's a very old way of working, because you're obviously making changes that can't go out into production for whatever reason. Whereas a much better way of working in my mind is to actually make sure that everything works before you merge it into your release branch. You're sort of saying, okay, I want this in my development branch, but I don't want it to go out for whatever reason. And if you don't want it to go out for a timing issue or whatever else, then put a switch on it and put a config switch. Turn this particular feature off or toggle it on when we need it. But cherry picking in terms of getting the commits that I want, the changes that I have made, because I have made a boo-boo and I want to reset things back to some previous point in time, but I actually want this particular change, is quite useful. So you can just take changes, because despite the fact that I've pulled back from this commit to this commit, these still hang around for a while. Git will eventually clear them up, but they will hang around for a little while, and you can pull them out and apply them to your branch. There was something else I was going to cover, and it completely fallen out of my head. There was cherry picking, branches.
Hunk updates or Hulk updates with interactive ads.
Oh, yes, rebase with rebase interactive. That was what I was going to talk about. There's another way that you can use rebase. This is a good way of using rebase. Actually, let me do the. Is it this way? So So what I've done with that magic command, git rebase. So I want to make changes. I want to replay things. -I interactive, and then head, and then this funny thing means 1 commit before. And in fact, I think I'm going to do that and say 2 commits before, 5 commits before, to save you having to just pull the hash off. You're like, I want the last 2 commits. No, I don't have 2 commits. Okay, so we'll just do 1 commit. And we can now say that I want to pick various things. So I can actually excise various commits. I can turn around and say, right, drop this commit. So if you've got a situation that's kind of the inverse of what I've described before, you've made lots of changes and I just want this one particular change, I can cherry pick. If I've made lots of changes, but there's one change in the middle of that that I don't want, I can drop it. And if I want to reword my commit, I can change this and say, reword. So my commit message of 2 is not good. I want to change that commit message. Something that bites me a few times is you cannot change that commit message here. All you can do here is pick what you want to do with each commit. Pick just leaves it as is. You can reword your commit. You can edit the commit, so it'll stop doing the rebase and you can make some edits. Squash is if you've got a huge amount of changes where you've been playing with things and you don't actually want people to or people won't care about the 20 different commit messages you've got, you can squash them all into a single commit and say, right, this is what I've done. I haven't used any of the other ones, but you can go read up on them. The R reword is the one I use quite a lot. So we'll write this out, quit that, and then it opens up my editor again, because this is now saying, what commit message do you want here? And this happens, I have Bitbucket set up on most of my repositories to reject any commit that doesn't have the issue number in it. Because if your commit messages are poor, at least you can then go off and have a look at your issue and see what was going on there. So it may be that my commit was rejected. So you put an issue number, and then you can put in a much better message. Go. And there, that's come out. I'll check out master. I've got a bunch more. Is it tool 5? That's it. Bunch more changes in there, so I could have gone off and maybe squashed a couple, dropped a couple. So there's a nice way of quickly just going through and changing things. It would be nice, and I haven't worked out how, but it'd be nice to be able to reword all your messages in this particular thing rather than having the editor open a few times. If you've got a lot of commits and you've forgotten to put the issue number in quite a few of them, it can be a bit boring, a bit dull. Loads of notes in the comments down there. Git tries to be helpful. I don't help myself because I never read the notes. I just see them come out and I'm like, oh yes, I need to do something, and then don't actually read what they're saying. And I've had to use git rebase -I for some quite hefty rewrites of the history where things have gone wrong, where people have been misusing rebase and merge. It was a fun time when I was just learning how to use Git, and people in the team didn't understand how to use it, and I didn't understand fully about rebases, and it was a nightmare. That's why I use my very simple workflow. Update your master, check out your branch, push it up, get it reviewed, merge it in, tag it when it's ready to release, delete your branch, update your master. Nice and simple. How long have I taken? I'll not be keeping an eye on the time.
Yeah, you're double.
Am I double? Oh God, hour and a half. Why didn't you say anything?
I actually meant an interactive ad, by the way, not an interactive rebase.
I've not done an interactive ad. Oh. Do I yield the screen to you?
I can take over the remote. Yeah, one sec.
Okay, I yield to Alex. I'm going to learn something. This is something I hoped. There's learning. Oh God.
I can't type.
No, I may need to. I may need to reload.
Well,
It's asking permissions and things.
Jacob wants a repeat of your stages for your flow.
Oh right, okay, yes. We can get those. What am I? Let me just give access to Zoom. Yeah. Waiting for Alex Scotland to control your screen.
Ah. And you can repeat your moments of flow, and I'll do this git add thing.
Okay. So is this my workflow or the Git flow?
I believe it's your flow. Yeah.
Okay. So my workflow: Git pull origin master main, whatever you've called it. The reason why I do that is just to make sure that I'm working off the most up-to-date version. I will then do a git checkout -b branch name. I always have an issue associated with branches. So it'll either be issue dash the issue number if I'm using the inbuilt issue trackers from GitHub and Bitbucket because they're just numbered, or it will be the Jira ticket number because for my sins I use Jira at work. Do my changes in that branch. Generally, I will try and keep that branch alive for hours, a couple of days at most. When I'm done, I have a command called git review, but that git review command just does git push origin branch name and opens up the lovely little URL that Bitbucket gives you in order for the code review to happen. Once that's merged in, I then git checkout master, git pull origin master, git branch minus lowercase d branch name to get myself back into a nice happy state. The lowercase d means that I can be sure that my branch has been merged. Sometimes I forget to actually approve the pull request for whatever reason, get distracted, and then you suddenly realize, oh, I haven't actually applied that change. And that workflow is nice and simple. It's nice and scriptable. So I have git new, git review. So git new, type in the issue number. Git review will do that thing. There's git update, which just doesn't open the URL. It just doesn't git push origin issue number, and git done. So those are my four little scripts. They're very, very naughty. It's in tilde.bin.
Or are you talking to me?
Yes. I just saw what you're doing with which git review.
I can't select this.
Oh, okay. Hang on. Have you got it?
Got it.
Lovely. So most of that is just dealing with getting the branch name, formatting it so it's in the correct format, putting some output out there. Actually, I was checking to see it's in the correct format because I should be using the same. It should be the same sort of layout. I set output to the output of git push origin branch name. The funny two chevron &1 just says send standard to standard out. I then echo that output because I've captured it all, and then I echo that output to pull out the URL, so I can then open that URL. So most of that is just convenience fluff. What it's actually doing is a git push origin branch name. That's the fundamental bit that happens there. The only other part of my workflow, which was not included in this really, is that I have a Bitbucket pipeline set up to fire when a tag is created, and that will do a release. So Bitbucket is actually set up when I push, for most of my branches, when I do a push, a build will happen. And so that when you're doing that code review, you can check that the build has successfully completed as well. and that build includes a whole load of linting, so you can make sure that your code is up to standard. Then when you merge into your main branch, it promotes up to any staging environments that you may have, and then when you do that tagging, it pushes it to production. And in some instances, we'll actually launch that particular version. So I had some stuff running in Fargate, it just pushed that up and reload it. Alex, do you want to do your interactive ad?
Yeah, sure. So I've added, this is basically what I quite often do because I don't end up following the rules that you laid out with the nice small commits. And what I end up doing is writing loads and wanting to then package it up into some smaller commits.
Oh, right.
So
Okay.
if you ever find yourself in that situation like I do, so I've added 2 lines to that README text. And instead of using git add just normally, just adding the README, if you do git add -I, oh, and don't hit enter twice, that won't work. All right, you'll get this little prompt here. And I can do a patched add. So I'll say number 5 or P, and then it will show me which files are available. So obviously it's just the README, and I've got 4 editions in it. So if I tap 1 here, it's now got a star next to it, so it's been selected. When I tap enter again, it'll start splitting up the git add, and usually sometimes this will have a loads in here,
Right.
but you can use S to split it down, or you can optionally then just stage this hunk. So if I say yes to this, and then the second line, actually no, I don't want that line. We've now got a staged add, and I can just Q, I think, out of this, and then git status, and it'll show the README line on both.
All right. Yes.
And then if I git diff it, I only see that second line, so I can then commit that away. Oh.
Above the feature.
Of a feature. That's introducing a bug. And then yeah.
I have learned something new. That's awesome.
Sweet. I use that a lot.
That's nice. So you can then sit there. Of course, I do multiple commits. Every time I save, I commit. Git add -I. That is pretty cool. Are there any other outstanding questions? Anything anyone else wants to show? No? Apologies for overrunning. I was kind of expecting Alex to say, "You've run out of time."
We were in the flow. We were going through things. Yeah, that was good. Thank you.
So everyone should now be in a position to use Git in their day-to-day work. You may still need to ask for help if you get into trouble, but if you're using that nice simplified workflow, you shouldn't really get into trouble. And if you're using a UI to handle your merge conflicts, then the horribleness should go away.
And a repeat on that IDE. I think it's the multi-billion-pound one, isn't it?
Oh, I use IntelliJ Ultimate.
Yeah, there are plenty of free tools around. Sublime Merge is license-ware, trialware. That's free. Does exactly.
I
think
imagine
it does pretty much all of that stuff. Yeah, VS Code's put it in.
And there are things like SourceTree. There are tools you can download to do the visual merging. It just happens to be built into my IDE. So I use IntelliJ Ultimate because I program in a number of different languages, and I want all my projects in the same place. And this is the only JetBrains product that will let me to do it. But as Alex said, it's not cheap. It's, I think I've got a personal license. I think it's 250 quid a year. I use it a lot. It's
That's a
worth it.
disgusting amount of money to spend on a slow IDE. Anyway,
Don't let me pay off the Sublime. But yeah, this is just the IDE, and I use others. Others exist. Others do it. Eclipse does it. Visual Code, the Microsoft C# one, does it. And yeah, there are loads of different Git UIs. Bitbucket produce one. GitHub, I think, produce one. There's a bunch of stuff out there. Don't feel that you need to shell out money for JetBrains, no. Unless JetBrains will give me a free license, in which case shell out money for JetBrains.
JetBrains. I think we should. It seems apparent we should do a session on CI, pipelines, GitHub Actions, and things like that. So what you can actually be doing to react to these code changes. So as you're pushing these things to Git repositories, you can be kind of acting on them within these Bitbuckets and these GitHubs and these GitLabs. Oh, there we go. There's a pipeline to
very
to run CI.
Very simple. But it does a bunch of stuff.
Okay.
I actually have a project called GoBase that will go off and put that basic pipeline and stuff in there, because I use the same base for all projects. So I just set up a bunch of things.
Brilliant. Right. Well, I'm going to say adieu and farewell to our YouTube following.
I half the internet.
Drop off of the stream unless there are any other questions in there. I don't think there are. So yeah, we'll drop off the stream. Thanks for joining us. Don't forget to subscribe. Helps out the channel, all that jazz. I think we meant to shout really loudly as well. Is that the thing that you do on YouTube? Shouting? Right. Anyway, bye.